The Life Cycle of Stars. Chapter 1. Introduction to the Cosmos. Before we begin our journey through the life cycle of stars, let us take a moment to imagine the vastness of the universe. Picture yourself floating gently in space, surrounded by the soft, twinkling glow of distant stars. The silence is profound, and the darkness is infinite. Stars, like quiet lanterns, dot the fabric of the cosmos, illuminating the void with their ancient light. For billions of years, stars have lived and died, forming the galaxies, planets, and elements that make up everything we see around us. They are not eternal, though they often appear to be. Stars are born, they live, they change, and eventually, they fade. As we begin this calm exploration of stellar life, we will trace the journey of a star from its very beginning in a cloud of dust, through its long and radiant life, and finally to its quiet or catastrophic end. Each chapter in this story is written in light, in time, and in gravity. Let your breath slow, let your mind drift, and let us begin. Chapter 2. What are stars? Stars are not just points of light in the night sky. They are immense burning spheres of gas, primarily hydrogen and helium, held together by their own gravity. Inside, nuclear reactions fuse atoms, releasing the energy that makes them shine. The Sun, the closest star to Earth, is a middle-aged star. It gives us light, heat, and the very conditions necessary for life. But in the grand scheme of the universe, our Sun is just one of hundreds of billions of stars in the Milky Way galaxy alone. Stars come in many types. They can be massive or small, hot or cool, young or old. Some live fast and die young. Others burn slowly, lasting for billions of years. Their mass determines much about their destiny. To understand the life cycle of a star, we must first understand its building blocks and the forces at work within it. Chapter 3. Stellar Formation. The birth of a star begins in the quietest places of space, cold, dark clouds of gas and dust known as molecular clouds. These regions, sometimes called stellar nurseries, are cradles of creation. Over time, the pull of gravity causes parts of the cloud to collapse inward. As the material condenses, it forms a dense core. This core heats up as it contracts, and when the temperature at its center becomes high enough, nuclear fusion begins. This moment marks the birth of a protostar, a star in its infancy. The protostar is shrouded in dust. It may take thousands or even millions of years to clear away the material around it. As it matures, it settles into a stable phase known as the main sequence. All the while, pressure from fusion pushes outward, balancing the inward pull of gravity. This balance is delicate, and it defines much of a star's life. Chapter 4. Main Sequence Stars. When a star reaches the main sequence phase, it enters the longest and most stable part of its life. Here, hydrogen atoms are fused into helium in the star's core, releasing a tremendous amount of energy. The Sun is currently in this phase, and has been for about 4.6 billion years. It will likely remain here for several billion more. Main sequence stars vary in size, brightness, and color. The most massive stars burn hotter and brighter, but live shorter lives. Smaller stars burn cooler and more dimly, lasting much longer. Color tells us much about a star. Blue stars are the hottest. Yellow stars, like our Sun, are in the middle. Red stars are the coolest. Despite their brilliance, main sequence stars are in a state of quiet balance, but this cannot last forever. Eventually, the hydrogen in the core runs low and change begins. Chapter 5: Red Giants and Supergiants. When a star exhausts the hydrogen in its core, the delicate balance begins to shift. Gravity causes the core to contract, while the outer layers expand. The star becomes a red giant. In this phase, the star swells many times its original size. Its outer layers cool and redden. Inside, the core continues to contract and heat, igniting new fusion processes. Helium is fused into heavier elements like carbon. The red giant phase is dramatic, but relatively short compared to the main sequence. For massive stars, this stage becomes even more intense, leading to supergiants, enormous, luminous stars on the brink of collapse. This is a time of instability. The core battles gravity with each fusion cycle, but the end draws near. Chapter 6: White dwarfs, neutron stars, and black holes. What happens next depends on the mass of the star. For stars like the Sun, the red giant sheds its outer layers, leaving behind a hot, dense core, a white dwarf. This remnant is roughly the size of Earth, but far more massive. It glows faintly, slowly cooling over billions of years. Heavier stars face a more violent fate. When fusion can no longer support the core against gravity, it collapses suddenly. In the heart of massive stars, this collapse creates a neutron star, a city-sized object so dense that a teaspoon of its matter would weigh billions of tons. In the most extreme cases, if the core is heavy enough, even neutron degeneracy pressure cannot stop the collapse. The result is a black hole, a region of space where gravity is so strong, not even light can escape. Each outcome is awe-inspiring, and each marks a kind of death, or perhaps transformation. Chapter 7: Supernovae and Stellar Death. For massive stars, a death comes as a spectacular explosion, a supernova. This brilliant event occurs in the final moments of a massive star's life. When the core collapses, shock waves blast through the star, tearing it apart. The explosion releases more energy in a moment than the sun will in its entire life. Supernovae light up the sky, often outshining entire galaxies for a brief time. They are rare, but essential. These explosions scatter the elements formed in the star's core, carbon, oxygen, iron, into the surrounding space. These elements seed future generations of stars, planets, and even life. So in death, a star gives back to the cosmos. It enriches the galaxy. It plants the seeds of worlds yet to come. Chapter 8: The Rebirth Cycle. The material from dead stars does not disappear. It returns to the interstellar medium, the vast expanse of gas and dust between stars. Over time, gravity gathers this material again into clouds. These clouds may birth new stars, continuing the cycle. This process has repeated countless times. The atoms in your body were once part of ancient stars. You are, quite literally, made of stardust. Each new star contains within it the legacy of countless others that came before. The universe recycles. It remembers. Chapter 9: Time and Perspective. A star's life spans millions to billions of years. Compared to our own lives, their time seems endless. And yet, even stars do not last forever. Our sun is halfway through its main sequence life. In about 5 billion years, it will become a red giant, and eventually a white dwarf. But stars more massive than the Sun may live only a few million years, and smaller stars can live for tens of billions of years, far longer than the current age of the universe. These timescales humble us. They remind us of the immense patience of the cosmos. Nothing is rushed. Everything unfolds in its time. Chapter 10: Cosmic Meditation and Recap. Let us now rest in the knowledge we've explored. We began in the silence of space, where stars are born from cold, dark clouds. We watched as they ignited, burned, and lived in balance. We saw them grow, swell, and finally collapse. Some ended quietly as white dwarfs, others ended violently as neutron stars or black holes, and still their matter lived on. Each star is a story, a journey, a light that flickers for a time and then fades. As you drift towards sleep, imagine the stars above, distant, ancient, and radiant. Their light travels across space and time, whispering the secrets of the universe. Let your breath follow the rhythm of the cosmos, slow, steady, eternal. Good night. End of lecture.